محمد وعلى آله وصحبه أجمعين. This is section 3.1, and the last point in this section is about box and whisker plots. And we discussed last time the steps we must use to construct a box and whiskers plot. And the first step is to sort the values. We also solved an example. So let us solve an exercise today. So we have these numbers, and the question is construct. In part B, he will ask, construct a box and whisker plot. So let me start by sorting the data. If you look to the data, you can see that 0.86 is the smallest, then 0.88. We also have 0.9, 0.93, 0.94, 0.95 twice, there is also 0.97, 0.98. There is also 0.99. Then I have 1.03, 1.05. There is 1.03 twice, and then 1.05, and there is 1.09, three times. And then we have 1.1 twice. And there is 1.13. So if you count these numbers, 1, 2, 3, these are the positions. This is the number in position 5. This is the number in position 10. This is the number in position 15. Okay, by this I make sure I have 20 numbers. I hear also 2 times 10, 20 numbers. So that's good. This is, we sorted all the data. Now compute the mean. Well, to compute the mean, I have to read the question. Is it a population mean or a sample mean? To justify their suspicion, the manufacturer randomly selects 20 chickens. So this is a sample of 20 chickens. And these are the weights in kilogram. And the manufacturer found there is a huge variation in the weight of chickens. So he was suspicious whether there is a huge variation in the weight or not. So to find the mean, it's the mean of a sample, so I call it X bar. I add all the numbers, so 0.86 plus up to 1.13, and I divide by 20, and I get the answer. So I'll do that by calculator. If you want to do it with me. Okay, it is 20.06 over 20. So the answer is 1.003. So that's the mean. So you can In part B here, he said interpret your findings in part A. So this is the mean. So this is the average weight. The average weight the average, or you say the mean weight of the 20 chicken is 1.003 kilogram. The median and the mode. Well, the mode is the most frequent. So if you look to the numbers, 1.09 was found 3 times. It's the mode. So you can mention here that the most frequent weight is 1.09. To find the median, I need to sort the data. They are sorted. I need to find the position of the median. The position of the median is 20 over 2, which is 10. It's an integer. So I have to go to the number between the 10th and 11th values. So the median is here, between the 10th and 11th. So to find the median, I add 0.99 in the 10th position plus 1 in the 11th position, and I divide by 2. I get 0.995. So that's the median. So you can say to how to interpret the median, you can say 50% of the weights are less than 0.995 kilograms, and 50% of the weights are higher than, are more than 0.995 kilograms. Let me notice here to remind ourselves that X bar is greater than the median. And we studied if X bar is greater than the median, this means that the data or the distribution is slightly because not really much difference between them, slightly skewed to the right, because the mean always goes to the skewness. If you remember, we said that the graph would be like this, skewed to the right. For here would be the mean, here would be the mode, the median, sorry. The mode is here. فالميديان is to the left of X bar. X bar is greater than, فعلى طول skewed to the right. Notice that the median goes away from the skewness. The right skewed, the median goes to the left. بينما X bar goes towards the skewness. Okay, part C, construct a box and whisker plot for the chicken's weights and determine the distribution's shape. Already we determined the distribution's shape, but we can also determine the distribution's shape from the box plot. Let me tell you how. If you find that, let me say left skewed, it would be left skewed, the distribution would be left skewed if the median is to the right, not in the middle. And the left whisker is longer than the right whisker. If these two happens, we say that it's left skewed. If one of them happens and the other does not, we deal with this one. This is the most important one. Okay. It would be right skewed if the median lies to the left and the right whisker is longer than the left whisker. It would be symmetric if the median lies in the middle and the right whisker is equal to the left whisker. They are equal. Okay. After you construct the box plot, you can talk also about the shape of the distribution. So we learned two methods now to talk about the shape of the distribution. One by comparing the mean and the median, and one from the box plot. After sorting the data, we need to find Q1, Q2, find Q1, Q2, and Q3, and then we draw the box. Okay. So let us find Q1, Q2, and Q3. Q2 is the median. So Q2 is already found. It's 0.995. So to find Q1, I need to find the index. Q1 is the 25th percentile. So 25 over 100 times 20. 20 is the number of data. We have 20. If you multiply 20 times 25 over 100, you get 5. It's an integer 5. So you go to the data and choose the value between the 5th and the 6th position. So Q1 would be in the middle here. So it's 0.94 plus 0.95 over 2. So Q1 would be 0.94. And if you ask yourself, what is the number between 0.94 and 0.95? Actually, the answer is 0.945. Because here you have 0.94 and here you have 0.95. Now this one would be 0.941, then 0.942, then 0.943. So here in the middle you have 0.945. Q1 is 0.945. To find Q3, it's the 75th percentile. If you multiply, you get 15. So Q3 is the number in the middle between the 15th position and the 16th position here. Okay, here in the middle, this is Q3. Now, if you find that here Q3 and here Q2 and here Q1, one way to find that your answer is correct, you did not do a mistake, to count how many numbers we have to the right of Q3. We have 4. Between Q2 and Q3, we have 1, 2, 3, 4, 5. We have 5 numbers to the right of Q3. 1, 2, 3, 4, 5. 5 numbers between Q3 and Q2. 1, 2, 3, 4, 5. 5 numbers between Q1 and Q2, and 5 numbers to the left of Q1. So that's good. Now Q3 should be in the middle between 1.09 and 1.09. Well, the number between 1.09 and 1.09 is in fact 1.09, because there is nothing in between. But if you want to use the formula, add divide by 2, you will get also 1.09. Okay, so next I find the lower limit and the upper limit. The lower limit, by definition, it's Q1 minus 1.5 times IQR. Okay, Q1 is 0.945 and IQR is Q3 minus Q1. So if you subtract Q3 minus Q1, 1.09 minus 0.945, you will get 0.145. So that's IQR. So 0.145. So 0.945 minus 1.5 times 0.145, you have 0.73, so that's the lower limit. The upper limit, you add the same amount to Q3, so it's Q3 plus 1.5 IQR. Q3 is 1.09. I add 1.5 times 1.45, and I find that the answer is 1.31. Now, after you have the lower limit and the upper limit, you can determine the outliers. If you look to the data, the lower limit is 0.73. The smallest number in the data is 0.86. So there is nothing less than 0.73. So there is no outlier to the left. The upper limit is 1.31. The maximum number in the data is 1.13, and that's less than 1.31. So there are no outliers. There are no outliers in the data. This means that all the weights of chicken are good, no outliers. So there is no need of suspicion. Okay, there is no suspicion. And some weights are a lot of variation between the weights. No, there are no outliers in the data. Now, the most important point is to try to graph a nice graph for the box plot. So you start by the smallest number, which is 0.73. I can start by 0.7, for example. Okay. So what is the largest number I need to reach? 1.3, because 1.3 is larger than 1.13. Sometimes, if there are outliers, then there are numbers in the data greater than 1.3. So you have to go more than 1.3 in your number line. So if this is 0.7, I can choose this to be 0.8, 0.9, and this is 1, 1.1, 1.2, and 1.3. So that would be enough. Now Q1 is 0.945. Well, this is 0.9, this is 0.95. So 0.945 is almost here. So this is Q1. Q3 is 1.09. This is 1, this is 1.05, 1.09 is here. So this is Q3. Now you can draw the box between Q1 and Q3. And then you draw Q2 in the middle. Q2, the median, is 0.995. So 0.995, this is 1, 0.995 is here. So this is the median. It's to the left. So the shape of the distribution is skewed to the right because the median is to the left. Okay, so if the median goes to the left, the distribution is skewed to the right, and this is what we got also when we compared the mean and the median. Okay, now put the lower limit and the upper limits. This is 3, this is 0.75, so 0.73 is here. So this is the lower limit. The upper limit 1.31 is here. So this is the upper limit. Now, if there are outliers, they should be to the right of 1.3 and to the left of 0.73. But as we have seen the data, the smallest number in the data is 0.86. So this is 0.85, this is 0.86. This is the smallest number in the data. So you take it to the box plot, and this is the left whisker. The largest number in the data is 1.13. Yeah, 1.13. So this is 1.1, this is 1.15, 1.13 is here. So this is the right whisker. It goes to 1.13, and this is the box plot. Notice that the left whisker is longer than the right whisker. It suggests that this distribution is skewed to the left, but it is not the case because the median goes to the left and the mean is greater to the median. So we say that the distribution is skewed to the right. I'll stop here and I open the floor for your questions. Please, if you have a question.